Good afternoon, and my name is Mark Stiles. I'm going to be presenting on synthetic data for LLMs. And this is the NLP applications project for natural language processing IST 664. So let's start with what is synthetic data. So if you think of real data as anything you can capture out in the wild, social media feeds, information coming from sensors, around the world, anything like that you're capturing raw in the native, that is real data. Synthetic data is a copy of it that mimics the properties of it, but doesn't contain the values. And so there's a number of reasons why you would want to have information that mimics real data. And some of them here, like customizable to the business. So if you have a model you're trying to train, you don't necessarily have a lot of data stored. Maybe you're a startup, maybe you're just new to this. You want to be able to generate some data that represents what your business needs to build a model, but you don't necessarily have it. This could fill that gap. And so a lot of the reasons around this is that, obviously it's cost effective. If you were to go out and run a survey or try to capture real data from people, they have to pay for that. It's a lot of time, a lot of effort. Being able to do capturing information quickly or generating it based on information you already have, that's much more effective. It is quick to produce. Obviously, it's an algorithm. You can produce as much as you want or as little as you need. One of the main values here is you augment small data sets. So if you have some information, but you need more to get to that level where you're training to a certain competence, this can help fill that gap. It also helps balance the data set. So if you are trying to put together a classification algorithm, you have a good number of your classes have a lot of examples, but there are a bunch of classes that don't have many examples at all. Your algorithm is going to be biased against those ones that don't have a lot of examples. It's going to be always leaning towards the ones that it knows because it's seen them so many times. And so to be able to balance that data set, you could use synthetic data to provide examples for the other classes just to bring them up to par. And so that's one of the main sets, but I think the thing that draws me in, especially with LLMs, is that it helps maintain data privacy. And so one of the early research papers that I was reading was medical information. And so they were using synthetic data to replace actual patient data to train the models to be able to say that the model itself is secure, like it's not going to leak anybody's personal information. And so that was a really powerful use case to me, and obviously underscored the value of the LLMs. So here's some of the use cases that I found. So the detecting depression and suicidal ideation, if you're a medical professional and you're capturing the logs or the transcripts of medical conversations over the phone, over Zoom, or whatever it is, being able to check that against known data where people were actually depressed and did consider suicide, that's a really powerful medical use case. But obviously you don't want to be putting personal information into that model. You don't want to be training it with sensitive information that could compromise those people. So being able to train your data on the structure and the way that people speak, the types of words that they use, but not necessarily their personal information, that's what this is going to be really useful for. Another use case which I found really interesting was clinical trials. And so obviously one of the backbones of the science altogether, being able to put together a clinical trial is a really challenging thing. Finding the right people that meet the criteria to fit into a clinical trial can be really time consuming. Building an LLM model that can help ask the right questions and categorize people to the right clinical trial was actually a use case for the LLM. And so I thought that was really interesting. Another interesting case is language explanation consistency. And so this really gets down to the finer grained nature of the model itself. If you have a model, like let's say you asked a question like, does this bird fly? And it says, yes, all birds fly. And then you say, well, does a penguin fly? And it says, no. It's not necessarily consistent, right? It doesn't think that it knows that a penguin doesn't fly, but it thinks that all birds fly. And so being able to fill in those gaps, being able to get enough data to capture the contours of this nuance is really valuable. So that's another use case here. Machine translation and grammar correction are very similar. Right? For machine translation, you're trying to find examples where two languages actually have been translated by people in that language. And so you're getting really good contact with how this language actually moves between the languages. But in a lot of cases with languages, there's a lot of languages out there. Not all languages have translations to other languages, a lot of examples of it. And so being able to take what you have and kind of increase it just enough to get it to a point where you can train a model to do translation, that's really powerful too. Grammar correction is a very similar thing, right? You're trying to not just get it to replace words that are as good as the word that you used, maybe, you know, trying to put in a phrase that's equivalent but makes more sense. You want it to actually get to a point where it can teach you better words. And so words that are more interesting or you know, have more contact with the context that you're using, that's going to be improvement on the grammar correction. You know, being able to use synthetic data to push it past where it would be. That's a really interesting application. Sentiment analysis is the same, very similar thing, but obviously it's using sentiment. Small language model, similar to the machine translation. You know, you have this language, it doesn't have really a lot of examples. If you can increase the volume that you can get to use a model correctly, you know, but still maintain like a small model size. Maybe you're building up a small language model to begin with, just adding a little bit of information about this language and, you know, increasing the volume. You can really create these powerful language models for maybe regions that don't necessarily have a lot of support. But they can still get the value of these algorithms. In error correcting code, this was a case that I hadn't really considered, but it was interesting. And so when you're trying to have an LLM generate code for you, it's a language of its own type, but you have special cases because code has to compile. And so if you're generating code that seems pretty accurate, looks pretty good, but doesn't compile, people still have to go in there and fix that. And so if you can generate code that actually can compile itself, that's a really valuable thing. You know, being able to get that language generation to the point where it's not requiring as much intervention. So those are the use cases. Moving on, we'll look at some of the companies. So there are a number of companies out there that are already building synthetic data. And so you can hire these companies, you can pay fee for their generation. I won't go through all of them. I did find a handful that were just, you know, really interesting. They covered a lot of different business cases. But for the ones that really seem to relate to what I was talking about, the medical data, you have mostly AI. You have Gretel, and there's rendered AI. I'm sure many of them actually do cover privacy concerns. I think that was probably one of the use cases. I didn't dive all the way into each one of these companies. So there probably are a lot of them that do more than I think, but just based on their, you know, descriptions, these ones are already they promote that they are using privacy as a process to make sure that that information doesn't get compromised. So your medical data can be anonymized in such a way that it's still valuable to the business, but it's safe to do so. And so be aware that there are, if you have use cases, there's a number of companies already supporting this. And then there are Python libraries already in existence that you can go and you can use to generate data for your own use cases. So there, obviously in these classes, we have a lot of need to generate or find data sets. You could also try to take a smaller data set, make a bigger data set. You can generate a whole new data set from, you know, that you found a schema for, you think that would be useful to demonstrate. And so some of the Python libraries here, some of the most useful ones I've found here, you know, if you're collecting data points, you use data synthesizer or SymPy. If you're trying to create fake names, addresses, or dates, you can use Faker or PyDBGen or Mimesis. If you're looking to create a relational data, you can use Synthetic Data Vault. For sample data, Platypy is useful. The example I saw with Platypy was that it was able to take X-ray images, medical X-rays, and classify different body parts within the image. That was really interesting. I didn't I didn't dive into that one too much because it's kind of out of the scope, but it did catch my attention. It was really interesting to see how it could do that. For time series data, there's a couple of here. Time series generator, synthetic data vault. And synthetic data vault, I'll say they're supported by MIT, or at least I think it was initiated by MIT. They have a lot of a really robust product. I think it's really, if you were in a business case, you want to really get a lot of use out of it, and you want something reliable, I think synthetic data vault would be the first thing I would look for. And it seems to be, really a strong contender in the field. So I would think of that if you really do have a use case in your business. If you're trying to generate automatic generated data, you would look at Gretel Synthetics or scikit-learn. For more complicated scenarios or image data or video data, there's Mesa, there's ZPy, and Blender. Blender is actually a 3D modeling application, so you can only imagine what they're producing with that. It is out of the scope of the LLMs here, but still fascinating that they've been pushed that far nonetheless. Okay, so what I want to do is demonstrate some of the libraries that I found. Faker here, which was one of the first ones I found, I did find it actually very straightforward. Right? It does make sense. You can read it. It's pretty quick to take up. I think it didn't take a lot of effort to really get something interesting. And so you can see here, putting email, country, the name, text. Text is interesting because it obviously can produce what seems like really valued text, but it's not. And so that's curious. Some of the other features of this, which I found powerful, were that you could give it patterns for your email or your phone numbers and say, I want the emails to look like it's coming from this domain, generate, 1,000 of those emails, or I want a phone number with a prefix area code of this, and being able to generate that information. So you can target it to the specific thing that you're trying to do, and it doesn't take a lot of effort. The next one that I used was Py2BGen. And so this one's actually built on Faker. So it does a lot of the same things, but it adds a lot of other functions. One of the interesting use cases here is it can generate license plate numbers. You can also build an entire table just providing what the types that you want, and it'll just build a table for you. And that was, again, if you wanted to try something for a data set, this is really, really quick way to do that. Time series generator. So this one, obviously a little bit outside the scope of the LLMs, but I did find examples where they were using it for an LSTM model, deep learning model. And so there are cases for where you could use it for that. It wasn't necessarily a text thing, but it was augmenting other predictions. So there's all kinds of use cases that you could probably think of, but I wanted to cover at least a little bit outside of the scope so that you could see what was possible. Obviously here, what it's doing is generating a series of data that's sequential. Didn't take a whole lot of code to really write that. But it does have a lot of features. It's really robust, so you can do a lot of different things with it. And so here's a list of links. So this is kind of almost the final page here of the references that I used. There were 9 different research papers, all mostly from archive.org, one from doi.org. And some of the ones that I was finding with the medical explanations. And just a couple of interesting links in case you're really interested and you do think you could use some synthetic data, explanation of what it is, how to generate it, techniques and best practices. And then if you're interested in the synthetic data vault, there is a page here of the Colab that shows you basically how to take your data, train the model with it, and then generate synthetic data from it. So that's all I have. I appreciate your attention and thank you. I hope you learned something about synthetic data today.